Hello, it is nice meeting you through this lecture on ionic product of water through conductance measurements. Ionic product of water, as you know, it is a mathematical product of the molar concentration of the H plus or H3O plus and OH minus ions, that is hydroxyl ions. Water is a weak electrolyte. It dissociates feebly into H3O plus and OH minus. So the measuring of the concentration of these two ions from the water and the product of these two is called as ionic product of water. The measured value of these two concentrations gives you 1.0 into 10 to the power of minus 14 mole square dm to the power minus 6. The same value we can determine in this presentation, that is through conductance measurements. How do you do that? From the value of the conductances value of the ions, it is possible to calculate the ionic product of water that we shall see now. At 298 Kelvin, the specific conductance of pure water is 5.54 into 10 to the power of minus 6 Siemens per meter. The ionic conductance of H plus and OH minus ions are 394.8 into 10 to the power of minus 4 and 198.5 into 10 to the power of minus 4 Siemens meter square per mole respectively. Calculate the ionic product of water. Molar conductance of the H plus ion is 340.98 into 10 to the power of minus 4 Siemens meter square per mole, and molar conductance at infinite dilution of hydroxyl ion is 198.5 into 10 to the power of minus 4 Siemens meter square per mole. And the specific conductance of water is given in the problem, 5.54 into 10 to the power of minus 6 Siemens per meter, and these are all given in the problem. Finally asked to calculate ionic product of the water. So ionic product of water can mathematically expressed as, this is the product of the concentration of the H plus or H3O plus ion and OH minus ion. So we need to find out the molar concentration of H plus ion and molar concentration of OH minus ion, and taking the product of these two give you the ionic product of water. So how do you relate these data to calculate the molar concentration of H plus and molar concentration of the OH minus? That we have to see now. You know the relation, that is, to calculate the molar concentration of H plus or OH minus ions for an electrolyte, that is water. The relation is specific conductance of water by molar conductance of water at infinite dilution. Though specific conductance of water is given, molar conductance of water at infinite dilution, that should be calculated from the values of H plus and OH minus conductance at infinite dilution values. So in step 1 you can calculate molar conductance of water, and specific conductance of water is given, that will give you molar concentration of H plus. Finally, since there is 1 mole of H plus and 1 mole of OH minus are dissociated or ionized in the water, so that the molar concentration of H plus is nothing but molar concentration of OH minus. So you can take the product of these two, that will be the ionic product of water. That we have to do now step by step. Calculation of molar conductance of water, that is From the Kohlrausch law, you know that the sum of the ions of conductance at infinite dilution gives you the molar conductance of an electrolyte at infinite dilution. So substitute the values of H plus and OH minus conductance values, that will give you 548.3 into 10 to the power of minus 4 Siemens meter square per mole. Now calculate H plus or OH minus ion concentration in step 2. Specific conductance of water is given, that is 5.54 into 10 to the power of minus 6 Siemens per meter, and molar conductance of water at infinite dilution is given, that is 548.3 into 10 to the power of minus 4 Siemens meter square per mole. So H plus is equal to, upon calculation, 0.0101 into 10 to the power of minus 2 mole per cubic meter, 1.01 into 10 to the power of minus 4 mole per cubic meter. So approximately we can write it as 1 into 10 to the power of minus 4 mole per dm cube, because per cubic meter can be converted into per dm cube as conversion factor is 10 to the power of minus 3. So this 10 to the power of minus 4 will convert to 10 to the power of minus 4, that is while converting from per cubic meter into per dm cube. Finally, H plus is equal to 1 into 10 to the power of minus 7. Similarly, OH minus is also having the same concentration, 1.0 into 10 to the power of minus 7 mole per dm cube. In final step, calculation of ionic product of water, H plus and OH minus, take the value 1 into 10 to the power of minus 7 and 1 into 10 to the power of minus 7, and multiply these two, it will give you 1.02. Approximately we can write it as, or round it up to 1 into 10 to the power of minus 14, because 10 to the power of minus 4, 7 into 10 to the power of minus 7 gives you 10 to the power of minus 4. And also similarly you have to multiply the unit, mole into mole gives you mole square, dm raised to minus 3 into dm raised to minus 3 gives you dm raised to minus 6. So the final answer is 1.0 into 10 to the power of minus 14 mole square dm raised to minus 6. This is the ionic product of water at 298 Kelvin, calculated from the values of the conductance. So dear students, this is the another way of calculating the ionic product of water through the conductance value, and this is one of the application of the conductance measurement of the electrolytes, through which you can calculate the ionic product of water. Thank you for learning and keep learning. Thank you.